So my name is Sam Taggart. For those of you who don't know me, I've been doing LabVIEW for, at least 15 years now. I think I started in 2007. I've done a whole bunch of stuff. Got most of the certifications. Uh, yeah, I've been running a company called SAS Workshops for the past 8 years, trying to teach the LabVIEW developers, help scientists and engineers become better software developers. So all right, I'm going to share my screen. It is nice. I do see a lot of people that I recognize. So thank you guys for showing up. And thank you those of you who I don't recognize. Let's see. Everybody?
Yes, okay.
Looks great. Thanks, Sam.
Yes.
All right. So the title of this particular presentation is called Beyond NI Training. So I'm not here to completely bash NI. It may be easy to do that these days, but I do think NI training has a place. I'm not entirely sure that's necessary. I think there are other ways to get started. Can be a good way to get started, but it's not sufficient. So if you want to be a really high-level LabVIEW developer, you need to learn some techniques that you're not going to learn in the NI training. So the point of this presentation is to kind of point those out and point out what NI training is good at, so we can take advantage of the things that it's good at and where you can get the information on the things that it's not good at. So NI training, particularly Core 1 and Core 2, are really good at orienting you. They're really good at giving you a starting point. So if you know absolutely nothing about LabVIEW, NI Core 1 and 2 training are great, right? They teach you the very basics. They point you in the right direction. They point out some of the obstacles you're going to encounter. They don't necessarily tell you how to address those obstacles, but it gives you a good starting point. And as I said earlier, if you have questions, comments, you can feel free to interrupt me.
Sam, can you resize your screen? Is wider.
Okay,
too big.
cool. That I was afraid of. Let me. If I just do that, is that better?
Oh yeah.
Excuse me. Yeah. That works.
Hello. Yeah.
That work for everybody else? Okay, cool. We'll just do it this way. I don't know if I can make those any smaller. What is NI training good at? Well, I think it's really good at taking things that you may have learned in other programming languages like C or Python or something. For example, in Python, you might write a for loop for I in range 1 to n. And the NI training is really good at showing you how to do this. But it has some holes. There's some things that are missing. And the biggest thing that's missing is why. They're not really good at explaining why you do things a certain way. They're not really good at teaching scientists and engineers that software engineering or computer science way of thinking about things and breaking down problems. I mean, engineers are naturally good problem solvers, but there are certain techniques that just don't get taught, and that understanding, I think, is missing. And because there's no understanding, a lot of things in programming are very nuanced. There are certain things that can lead you into problems. Like one of the examples is using global variables, right? If you use global variables, you can run into race conditions, and you have this not being able to debug things. And because of that, because there's this danger, we just teach beginners, particularly in the NI training, we teach them a bunch of rules. Right? Don't ever use global variables. Do this, do that. Always create a VI description, and we teach all these rules, but we don't really understand why we're applying the rules and what the goals are and what we're trying to achieve. I have the saying, beginners learn rules and experts know the rules well enough to know when to break them, because a lot of times these rules are based on the fact that it's really nuanced in order to use some of these tools correctly. And so you just teach people not to use them or to avoid them rather than taking the time to teach them the nuance. And I feel like when you're an expert, you can get away with things like you can use global variables if you put them inside a library and you protect them so that everybody can't read and write from them, and you do the things to prevent race conditions. So that's what I'm hoping to get across in this presentation. Following rules leads to things like this. And if you look at this, if you don't know what this is Python code, but if you just take a second and read this and look at all the comments, right? The common example is, if any of you guys have ever taken a computer science course at all, or any kind of like engineering course where they taught you how to program, right? They tell you comments are your friend. And so they tell you to comment every line. And if you read this, the comments actually make the code less readable, right? Because there's so much noise. Trying to figure out what's actually going on is quite difficult. Anybody ever encounter anything like this?
Yes, very
Yeah.
definitely.
Yes, many times, and
Yeah.
from my own
And
code.
yeah. And in general, comments are good because we want our code to be readable. But there's some nuance as to when they're actually good and when they just add a bunch of noise. And so because we don't teach them the nuance, we just say, write comments all over the place. Okay? So there's things like that. And in LabVIEW, we have certain habits that we build up. I don't know if anybody's ever seen Darren Nattinger's presentation, but he gave a presentation called something like an end to brainless programming in LabVIEW. And he talks about some of these things. He talks about global variables and how, they cause problems. So we teach people not to use them, but there are some use cases where they make sense. The other one is the railroad tracks. So if you notice, if you do class-based, every VI has a class in and class out at the top and an error in and error out at the bottom, and you kind of train them together. But, some VIs, like a simple accessor for a class data, doesn't need an error out because it can never generate an error. And certain methods that don't modify the class data don't necessarily need a class out. And so by getting rid of some of these things, we can make our code easier to debug. The other one that everybody gets, right? We teach all beginners to put error cases around everything. And you open up a sub VI and it's got an error case around it, and all it's doing is like, unbundling a value or something. And that's really not necessary. And the last one is if you're doing VI server stuff in LabVIEW, we always teach beginners to close all their references. And that's generally good practice, right? You create a reference, you need to make sure it gets disposed of so you're not leaking memory. But there are certain references in LabVIEW, like control references, that don't need to be closed, right? And so adding all those closes just makes your code harder to read. And so I highly recommend you watch that presentation. I think it's pretty good, but it kind of hits on some of these points. And there's several other points. I think there's like 8 different points that he puts in there. If any of you guys have seen Darren's presentations, they're all good. So, excuse me. And actually, I don't have a link to it, but we should, before we send this out, I forgot to link to his presentation. And what's really missing from the NI training is kind of this idea of mentorship, this idea of experience. So you go to a class, and if you're lucky, you get an instructor with experience, right? Sometimes you just get like some fresh NI employee who's sat through the training once and they're out there teaching it. Sometimes you get really experienced people. But even if you have a really experienced instructor, yeah, you can ask questions while you're there, but when the class is over, there's no one to ask questions. And also, in the classes, particularly the NI classes, you go over these really basic examples. But then you go back to your work and you're working on this more complicated problem and you have questions of how to apply those lessons that you learned on the basic example to your problem, and there's no one there to ask. So that kind of knowledge transfer and mentorship is missing. And another thing that I think is missing is the NI training is very stuck in an old school kind of waterfall way of thinking and managing projects, very much top down, very much, gather all the requirements and then do all the design and then break it down to pieces and then hand all the pieces off to people and then kind of put it all together at the end. And modern software development has very much moved to a kind of an agile, iterative type of development, right? Where we're moving in small steps and we're constantly checking in with our customers and getting feedback and making sure that we're doing things correctly. Another area where I think the NI training kind of lacks is it kind of ends at NI's borders. So I don't know if anybody's noticed this, but NI is really good at teaching you how to use the NI products. They're not so great at teaching you how to use things like Git or how to do test-driven development or even unit testing or CI/CD. If you don't know what those are, we'll talk about what those are in a minute. But very much a closed ecosystem. And in reality, to make your project successful, you need a lot of other technologies. So, you need things like virtual machines. The advanced NI classes might mention that you should use virtual machines, but they never tell you how to set them up or what tools to use. They mention talking to databases, but they don't really tell you about how to set them up or what they're good for or how to use them. They don't really talk about JSON and web APIs and networking and how to do things securely. They don't teach you how to use CI tools. They don't teach you much about configuration management. And really, all these things are necessary in today's world in order to be successful as a software engineer. And one of my personal pet peeves is that NI takes these topics like test-driven development, CI/CD, unit testing, and Git, and it puts this expert badge on them because they only teach them in the advanced classes. And I really think, with the exception of CI/CD, I think unit testing and using Git and test-driven development are things that could be taught to complete beginners. I think one of the first things you should do is create a Git repository and check your code in as you're making changes to it. And as you're writing code, I think you should be taught to write unit tests, and you should be taught to write them first. The CI/CD thing is complicated. Enrique can comment to that because he and I have been working on that lately. But I do think there's also room there that NI could make that easier for people to get started with that. So any comments, questions? How many people have actually been through NI training?
I did a couple of classes.
So is what I'm saying tracking? Does it sound?
Yeah. I some of it afterwards, it was like I just had to sit there going, okay, great, what do I do?
That's a very accurate statement. Our company has a bunch of training credits. So yeah, you went through the classes and everything. And the first thing I ended up doing was calling old friends going, man, this is a great place to jump off, but where do I really pick this up on this project? And Sam, I think you hit it directly on the head, is that there's definite boundaries with National Instruments training. And everything you brought up is the stuff that I'm running into, picking the language back up after several years.
Mm-hmm.
Yeah, the other thing I noticed too is people, they go for like a three-day LabVIEW Core 1 training, and then they come back and it's like management thinks that they're suddenly now the LabVIEW expert and they throw everything at them.
That's what happened too. When I got back, I just went to I think it was Core 1, and my manager was saying, okay, we're gonna do this, this, and this. And then there was another guy there who was using LabVIEW, and he mentioned producer consumer, and I just gave him this blank look like, I mean, I don't even know what you're talking about. So it's, yeah, you're right. It is lacking. It's great training, but it's lacking in some stuff.
Yeah, I mean, I think to me, the real point is like, it's a good starting point, but they're not very clear about like advertising that, okay, once you take this, that's just the beginning. And I think customers get the message that, oh, we send our people to this 3-day training or week-long training, and now they're the experts, and it's not quite that simple.
Yeah, a good analogy would be, you're a craftsman, they've given you all the tools to build a house, you've got all the tools, but you can't build the house. It's just a big task. The mentorship is a key component to really getting on solid footing and adopting good quality practices.
Yeah, it's kind of like you want to build a house, so they teach you how to use the saw, they teach you how to use the hammer, they teach you how to use the screw gun, but they don't teach you how to read a blueprint, right? Or to draw a blueprint. And so, like, yes, you have the technical skills to be able to put things together, but and also they assign one person to build the entire house, right? Because they know how to use the saw and the hammer, and it's kind of daunting.
So in my classes, the first thing I tell participants, it's like after 3 days, all you will be able to do is open a LabVIEW project and close it again without breaking anything.
Yeah, I like to use the phrase.
And even that is an art. I mean, it's not easy.
Yeah, I mean, they know just enough to make a mess, pretty much.
Yeah, that's why I tell them hands off. And actually, yeah, the companies are sending people to standard trainings. Literally, like having them learn a new foreign language and expecting them to come back from a 3-day training and write a novel. That's the relation. Make it a house, make it a novel. It's the same. You will learn how to write a sentence. You will know some vocab, but you will never, ever write a novel. That's the image that I'm always using.
I like that. Can I borrow that?
You can borrow that, and I really love to exchange later with you another day maybe, because we are at sort of at the same point in our careers. Well, you might be more advanced, but I know how to teach LabVIEW, and I love to share my knowledge, but I see it's not in the context of NI trainings. I was an NI trainer, and I resigned because they were trying to also to tweak the rates and whatnot, and I go like, no, it's like you are a global player. You don't need to play me as a trainer. I'm doing advertising actually in those classes for this language and this environment. But hey, yeah, let's talk another day maybe. But yeah,
I have similar experience.
There's one more thing, another dynamic that everybody of you was dancing around. That's the presentations that happen in the NI courses. They are actually made, and I've seen that in other American or big tech companies, how training is structured. And training is, how should I say, it's constructed so any student right out of the uni can hold this class. They will not be able to answer anything in the audience brings up because they never ever had a project, but they will be put out there by this big tech company to give you some PowerPoint buzz, but it's just not helping any. And so it's the presentations and the exercises, they're well maintained and well worked out, but just don't ask anything that's not in that track.
Yeah. That goes along with their tech support.
You can't go off script then, pretty much.
Okay, but let's not go there.
Wow.
No,
Well, when you sit there and you realize you know way more than the guy supposed to be the application engineer helping you, you're going to kind of go like, I'm wasting my time.
Mm.
yeah, that is definitely a problem with NI. You know, a lot of the times you hire a class and they teach the AEs fresh out of college, and they go through the class once and then they start teaching it and they don't have any real world experience. I will say on some of the more advanced classes, they tend to get better instructors, but I think you made the point, I think, and I made this point to them, I think a lot of it is that they don't pay very well for their instructors, and so it's hard to get those high level instructors. So there are a few people willing to do that, and that's great. And if you can get one of them, that's really good. I know, you know, Alan and Fab teach classes and they really know what they're doing. And if you get one of them, it works out well. And there's some other ones as well. But all right, so aside from NI training, so that's kind of my bit on NI training and where the holes are. But I think as software developers, particularly software developers who are physicists, chemists, engineers by training and aren't software people, we really face two kinds of challenges. So on one side, we have the technical challenges. And I think one of the biggest ones is inheriting legacy code. So we have something that's been running for 10 or 15 years, and somebody hands it to us and says, here, maintain this. Right? And so that's a problem, because for two reasons. One, we don't have the skills. And two, often that code is not well written to begin with. Some of it may have been well written at the time that it was written, but that hasn't aged very well. And we lack some of the very specific skills. So we lack skills in refactoring. We lack skills in writing unit tests to test the code. We don't have the skill to change these houses of cards without the whole thing just falling down. And then we also have some challenges when it comes to designing new software, because again, we're not software engineers, we're not computer scientists. We have a basic understanding of algorithms, but we don't have that deeper understanding. And I also think, though, we face some non-technical challenges. So like dealing with people is always a challenge. I mean, that's like beyond software. But, when it comes to people, like how do you manage work? How do you take a team of people and assign it to different people and make sure it gets done? And and that kind of bridges the technical, non-technical, right? Because the non-technical is how do you break down the work and give it to different people? But then the technical part is, okay, I've got 5 people working on this project. How do I make sure they're not stepping on each other's toes and we can integrate all the code? And then the other one that I think we struggle with is selling ideas. So sometimes we have really good ideas on how to improve things. As an example, I don't know if any of you guys have been to NI Week or the GLA Summit or one of those places. But you go and you see a presentation on some great new topic, like, hey, unit testing, I'm going to start doing unit testing. And then you go to your boss and say, I'm going to start writing unit tests. And they look at you like you've got 4 eyes and they're like, no, we're not wasting time on that. And so I think building some skills on how to sell our ideas is also very useful. Questions or comments on that slide?
I actually have one. Some of the folks that I've worked with now, worked with in the past, they've used LabVIEW before, and what I see is they didn't have any training, so they just kind of threw some things together, and then when they had to build it out, they couldn't do it, and they were trying to compare it to a language that they already knew, and therefore LabVIEW is bad, no good, no one should use it. How do I try to persuade them that we need training?
Yeah, I mean, I guess one of the first things I would say is that people can make a mess in any language, right? So, I mean, we make a mess in C and Python and every other programming language. The beauty and the curse of LabVIEW is that it's really obvious when you make a mess, right? So you can't hide your mess, but also it's like on display for the world. So I don't really have a good answer. Other than like, if you were programming in C, you wouldn't hire somebody fresh out of college and expect them not to make a mess. And that's part of what we do in LabVIEW. And I wrote a blog post. I don't know, maybe it's the most recent one I put out. Can you see if that Taylor and pull the link up for that and throw it in the chat? I think it's about like training engineers. Oops.
Oh, cool.
Yeah.
I keep telling people the problem is, why do new hires get to work on large projects or considerable projects in LabVIEW without proper training? It's because they're cheap, and you can correct me on that, but I always keep telling people it's because LabVIEW was touted and sold for a decade. Hey, it's graphical. It's easy. You can click it. No, you can't.
NI is
just a picture. It's just a picture.
Yeah. The good thing is everybody can immediately recognize spaghetti code, even without being a programmer. But they don't react on it. There's nobody telling them. No, they don't even know there's VI Analyzer.
Yeah, I will 100% blame NI for that, because our marketing slogan used to be programming optional, and it used to irk me so much every time they would say it. So
programming optional, that was from NXG, I thought.
I don't know. I remember them touting it before NXG, but definitely NXG also is touted that way. So yes. All right. So
Thank you, Sam.
Oh, what?
Thank you. Thank you.
Yeah, hopefully that helped your problem. But yeah, read that article and just kind of, hopefully that resonates. I don't have a really good analogy, but I really like the analogy that was brought up about writing a novel, right? Sending somebody to an English class for 3 days does not qualify them to write a novel all of a sudden, right? You
English
can't,
as a foreign language, that is.
yeah, even in a foreign language, yeah. Well, even in English, right? Like if I went and took a 3-day English class, I wouldn't expect
Exactly.
to suddenly be able to write a novel, yet
Yeah.
alone in another language. So
But management does.
Yeah, they do.
yeah, I don't know. That comes to one of those phrases, something like change where you work or change where you work. So,
Yeah,
I mean, it's easier said than done sometimes, but like, you know, if you have influence, try to use it. And if you don't, either figure out how to get it or move somewhere else, I guess. It's the choice.
a lot of tears and a lot of gray hair. I'll tell you that much.
So when we talk about technical skills, these are kind of the 5 technical skills that I think are most important in modern software development. I got the top 4 from a book called The Agile Samurai. Taylor, we should throw a link to that in the chat too somewhere. And then I added the last one, Git. And I picked Git. It should say source code control because really I don't care if you're using Git or SVN, but Git just seems to have cornered the market on that. So let's talk about these for a few minutes. So unit testing, if you're not familiar with it. So often if you build a system, you have like a site acceptance test or factory acceptance test at the end, right? That the customer comes and witnesses before you ship it off or after you install it, that verifies the whole system works, right? And ultimately that's what we care about, right? We want the whole system to work. But as we're developing the system, it's really useful to inspect the individual pieces and building blocks of our system. So if we have a problem, we can narrow it down and immediately say, oh, it's this building block right here. And generally, if the individual pieces don't work, when we put them together, the whole thing's not going to work. Now, there are some issues that come together when we start putting stuff together. But at the basis, we need to make sure that each individual piece works. And so unit testing is just a way to inspect each piece as we build it and make sure that it does what it's supposed to do. And we can talk more offline or later about how we do that, but that's the general idea. And then test-driven development is basically saying, if you've ever read the 7 Habits of Highly Effective People, they talk about start with the end in mind. So TDD is about you start with, what do I want this thing to do? And then you immediately say, how am I going to test it? And so you write that test first, and that's this red-green refactor is kind of the TDD cycle. So you start by saying, what do I want it to do? Here's the test that I need it to pass, and that's the red stage. So you write the test fails because you haven't implemented the thing yet. And then the idea is you try to get to green as quickly as possible. So you write some code, and this you're allowed to be messy in this little bit, for this little period of time till you get it working. And you know that, okay, this thing that I want to do, I can do it, it's possible, I've got an implementation. And then you go back and you look at it and you say, okay, how can I make that better? And you go back and you do this refactoring step where you look at the code you wrote and you go back and you start changing it. But you have this safety net now because you've got this test that passes. So you make sure as you're making it prettier and cleaning it up, you're still passing your tests. And you kind of, what you end up with is a scaffolding around your code. You end up with this set of tests that kind of like make sure that the form of your code is correct and that it's doing what it's supposed to do. And I kind of think of refactoring. I'm an electrical engineer by trade. I don't know if any of you guys are, but if you've ever breadboarded something, some people have a knack for like doing breadboarding and keeping it nice and neat, but most people, when they breadboard, it looks like a complete rat's nest. You've got wires everywhere and it's really hard to tell what's going on. But typically the progression is you breadboard something, you get it together, it's a proof of concept, you get it to work and you say, yes, it works. And then the next step is to send out and get a printed circuit board with nice straight lines and wires, and it's nice and clean. And it's much easier to debug the printed circuit board than it is to debug the rat's nest of wires on the breadboard. And so that's kind of what we're doing with our code, right? We're doing the proof of concept first to get to that green state so our test passes. And then once our test passes, we're going back, we're saying, okay, we've got this to work now. How can we straighten all the wires and make everything look nice? Questions, comments so far? Is everybody familiar with the unit testing, test-driven development, refactoring? Is this new stuff for anybody?
That's new for me, but when you talk about the breadboarding, that's something I'm familiar with. So that kind of made it clearer to me, like an iterative process, right?
Yes, it's very iterative.
Yeah, thank you, Sam.
Yep. All right, so then we move on to CI/CD. So if you're not familiar with the other ones, this might be unfamiliar as well. So CI/CD stands for continuous integration and continuous delivery, or continuous deployment sometimes. It depends on who you talk to. So kind of means a lot of things to a lot of people. What I'm talking about in this context, so continuous integration means that every time you make a change to your code, in the background, there's a process that runs that combines your changes with all the other changes that have been made. And it runs a series of tests to make sure that it runs all our unit tests to make sure all the individual units work. And then it puts it together and it builds it and verifies that, yes, it can build with nothing broken. So if you've been doing LabVIEW for a while, you probably know that you can have code that works perfectly fine in the development environment, everything's fine, and you go to build it into an executable, and the executable build fails for some reason. So this is to catch those types of problems. And so I think of it as like a check engine light. So I'm doing my gets, I'm doing my code, I'm writing code, I make some changes, and then I commit it in Git. So I make a version of it, and I send it off to the server, and the server in the background runs. And as long as everything works, nothing happens. I don't get any notifications or anything. But if I happen to inadvertently break something, then it sends me a warning that says, hey, this thing broke, you should go fix it. And then the CD part of it, the continuous delivery or deployment part, is it's packaging up our code. So it's not only running, so first it runs all the CI part, all the tests, and then the deployment part is it builds an installer or package and it ships it off to the customer. And both of these are really about getting quick feedback. So the CI part, running the test, is about making sure that you're building the thing right, that it does what you intend it to do. So the unit tests tell you, the code should do this, and it's verifying that you built it right. The CD part is verifying that you built the right thing. So the CD part is about getting it to your customers so that you can make sure that when they told you they wanted you to add this screen that does XYZ, that you understood correctly what they wanted it to do. Because you're going to give them a version of it and they're going to go and run it and they're going to look at it and they're going to say, yep, that's exactly what I wanted. Or, oh no, can we tweak this? Can we change that color? Can we move this graph? Or, hey, when we said this, we really meant this other thing. So I don't know if you guys have any experience with that, but oftentimes, customers say something and we interpret it one way, but they meant something completely different. And so the CD part is about trying to make that time from I make a change, both CI/CD are trying to shorten the time from I make a change until I realize there's a mistake. Because if I make a change and I don't realize there's a mistake, I keep making more and more changes on top of that. And then when I realize there's a problem, it's hard to go back and change that thing. Versus if I change something and 5 minutes later, I realize there's a problem. Well, I'm still thinking about what I did. I remember exactly what I changed. And it's very easy to go back and fix it then. And nothing else has been built on top of it that I have to unravel to get back to where I was when I made the original change that caused the problem. Does that make sense to people?
Yes, thank you.
How many of you guys actually work in this way already?
No.
Okay.
I try.
Yeah.
Try to keep my customer, usually every few days, I'll say I made this advance. Am I still going in the right direction? Have feature creep changed my target and my goals? But as long as they haven't, then I continue to go.
Yeah. Yeah. So a lot of it too is also, giving feedback to the customer as well. So if you do this regularly, if the project is going to run over, it should not be a surprise to the customer, right? Because they're seeing your progress in real time. And so, if it's a 6-month project, 3 months in, if you're like only 10% of the way there, they're going to know. And it's not going to come as a surprise when you hit the end of the thing and you're like, yeah, I couldn't get everything done in time. So it's kind of a risk management strategy. And then the last part is using Git. So if you haven't used Git, on the left is a commit graph, is what they call it. Each of those circles represents a change in your code. So the way you use Git is it just kind of sits there and it watches your code. And every time you make a change, you tell it, hey, this is a change, and it gives it a version number. And it lets you can see at the bottom below where it says v1.2.3.4, there's multiple people. So you can have multiple people making changes in parallel, and then that circle where the lines come together, that is merging those two changes. So you've got two different people working on it, and then that you put those two versions together, and that's your version 1.2.3.4. And the key here is that your program, the thing on the right is supposed to be a program that's running. It's somewhere on it, it says exactly what version it is, so that if your customer reports a problem, you can go back into your into Git and into your source code, and you can see exactly what code they were running. And this is super useful because sometimes, you know, your customer will say, "Hey, I've got this problem," and you're like, "Well, I thought I fixed that." And you go back and they're running an old version. So that there, the answer is really easy. You just say, "Hey, upgrade to this new version that fixes the bug," and it's done, and it saves you a bunch of time from chasing down problems. It also makes it very easy to fix problems because with Git, you can, you know, if there's a problem in version 1.2.3.5, you can see what changed between 1.2.3.4 and 1.2.3.5, and then it narrows down where you look for changes. If only 3 files change between those 2 versions, well, then the problem has to be in one of those 3 files. So it's a really, really useful tool. So that's it for the technical tools. For non-technical skills, we've got skills like communication, right? You got to communicate and coordinate amongst various people that goes to the collaboration. There's the project management side of how do we break apart a project? How do we assign tasks to different people? How do we make sure everybody's on the same page? And lastly, I think there's an empathy component, which is, you know, how do we make sure that what we're designing actually meets our customers' needs? How do we make sure that we're doing it in a way that, you know, people aren't getting burnt out and that people feel like they're part of the team and contributing? And how do we handle all of that? Now, I don't have a ton of stuff on the non-tech skills, but I'm going to give you some resources in a minute. So we're on to the resources section. So if anybody has any that I'm missing, please throw them out. But for the non-technical skills, there is a group called Empathy in Tech. They have a Discord group where you can go and talk about various topics. And they organize free events all the time, like how to communicate with non-technical people, which is really useful because it's a good way to make sure that your boss actually knows what you're working on and sees your value. And it's also a good way to sell your ideas. So if you have an idea on how to make things better, that's really useful. Our podcast episode that came out today is with Andrea, who is one of the founders of Empathy in Tech. So she talks a lot about that. Taylor, you're going to say something? Was that what you were going to say? Okay. And then there's also a podcast called the Mob Mentality Show. So mob programming or ensemble programming is basically where instead of having, if you've got 5 developers, instead of having each one working on something individually, they all gather around one computer and work on one thing. But there's a lot of dynamics that come out of that and a lot of working with people. And they talk about on that show that idea of trying to get people to work together and what it's like and the challenges and how to sell to management and things like that. I'm very bullish on mob programming. I think it's the way of the future. I very much, you know, a lot of people are really into code reviews to try to ensure that your code quality is high. And I am very much of the opinion that mob and pair programming is much better for that. So you still get 2 eyes on everything, but I just think it's a much better way of doing it. And when it comes to selling your ideas, there is a video that I think is really great. It's 10 minutes. I highly recommend everybody watch both of these videos, but if you've got the fallacy is a 10-minute video talking about how a lot of people see writing unit test period as all this extra work. And basically GPaw breaks it down into all the different things that we do. So basically the premise is we think of coding as this one activity, but it's actually a bunch of different activities that go together. And when you do TDD, you do end up spending more time actually writing code, but all the other things that you do become less. And so it's actually more efficient. And it talks about that. And there's another really great presentation called The Economics of Software Development. And it talks about, you know, having a short-term versus long-term mentality. And yes, you can cut corners. And, you know, if your project is really, really short and really small, you can get away with cutting corners and it might be faster. But as the project grows, right, the cost becomes much more than doing it, quote, the right way from the beginning. I put that in quotes because there is no one right way, but it's a very interesting presentation. It will really help you. It teaches you some phrases like, I'm not writing tests, I am lowering the marginal cost of adding new features or something like that. And it gives you some language to talk to project managers and stuff that they can understand that makes sense and it helps you to speak their language. The next one is dealing with legacy code. So if you don't know, legacy code is basically somebody else's legacy, something that you inherited that you didn't write. And we all know it's challenging to understand other people's code, even when it's well written, because you didn't write it and it doesn't necessarily follow your thought process. Even if it is well thought out and well organized and all those things, it's still challenging. And so legacycode.rocks, they have a podcast, they have a Slack group, and the support group for people working on legacy code. So if you're frustrated or whatever, you can go there and talk to them and they'll give you ideas and help you out. And there's also a podcast called Maintainable that's also very good. It's more focused on the avoiding writing legacy code. So how can we write code so that in the future it's not a burden to maintain? And now we're getting into some LabVIEW stuff. So again, to revisit NI training, I do think NI training has a place. If people come to me and they know absolutely zero LabVIEW, I'm probably going to send them to LabVIEW Core 1 and Core 2 as a starting point. And then I'm probably going to sit and work with them and mentor them some more. But that's a pretty good way to start. The thing I have at the top, I don't know if anybody knows about the NI training and certification membership. But when I started, my boss, I have to give him credit, he bought that for me. It was like, I think it was like $4 or $5 grand back then. And each class is like $2 grand. So if you buy the training and certification membership for an entire year, you get to take as many classes as you want and certification tests. And so if you're bringing on a new developer and they don't know anything, it's a really good deal. You buy that, you send them to several classes over the course of a year. And in a year, you can get through at least the beginner and some of the intermediate classes. And it's really useful. And it's an affordable, effective way to do that. And the advanced classes, the Actor Framework one is really good. The other two, so-so. I mean, managing software engineering touches on some important topics. It touches on some of the Git and test-driven development and some of those things, but it really, again, it ends at NI's borders and it doesn't do a great job, but it will get you thinking about those things, which is good. But you take that class and you're left with more questions than answers. You're like, I should be doing all this stuff, but I don't know how to do it, which I guess is better than not knowing that you should do this stuff at all. Advanced Architectures has some, it's really technical and there's a lot of good technical stuff and like, how do I do XYZ in LabVIEW? Teaches you how to use subpanels and do GUIs and lots of fancy stuff. Some of the stuff they teach you, like they teach you how to use X controls and like nobody uses X controls because they're just crazy hard to use and there are other solutions. But you know, if you've got some free time and a few extra bucks, it's worth looking at some of those. But now for non-NI resources. So I don't know if anybody's ever looked at Tom's LabVIEW Adventure, but Tom McQuillan is an amazing teacher.
Yes.
And yeah, he is by far the best teacher in the LabVIEW world.
Wow.
Hands down. He has a way of taking complicated things and making them really simple and breaking them down so they're easy to understand. And he's got a bunch of videos that range from beginner to advanced. And I mean, if you do nothing else, if you go watch his videos, you would be very well off. 6Clear offers some training very similar to the NI Core 1, Core 2. So if you want to do that type of training, but you don't want to spend money with NI, you can go look there. DQMH is the Delacore queued message handler. It is a framework for creating basically modules that talk to each other and communicate. So it's very clear, like where it helps when breaking down your project into different areas of responsibility. There's training available on that. There is a group called SAS Workshops, which is I forget, it's Delacore, SSDC, Hamplesoft, and I think Brian Powell's also in that. So it's Fab, Steve, Jorg, and Brian Powell, and they do some good work. They teach a lot of stuff around process. So one of their big things is going through a project from, okay, I got this new project. Where do I start? How do I quote it? How do I estimate it? How do I gather all the requirements all the way through building the project, all the way into supporting it? And so they're really good with that. We are doing a joint workshop at GDevCon NA. So if you want to come to that, gdevconna.org, you can go buy tickets. And when you buy tickets, there's an option to purchase the workshop. It's a full day workshop on Monday. We're going to talk about all those stages of a project. There's a LabVIEW Wiki, which is just kind of for reference, but it's got lots of good stuff. There is a LabVIEW Discord. I don't know how to get an invite link, so if you want to invite, send me an email. If you're not on there, I can get you on there. It's not very exclusive. It just, they don't have a public invite. There's Lava forums, so what stands for like LabVIEW Advanced Virtual Architects or something. There's the various GDevCons. There's one in North America, Europe, and Australia, New Zealand now. And there's the GLA Summit, which is a virtual summit. I do realize we're at time, so if anybody has to go, we will provide this with all the links. I'll be a little self-serving. What do we at SAS Workshops offer? So I have a blog with almost 350 posts on all kinds of various software engineering topics. We have a podcast that we put together called the LabVIEW Experiment. If you haven't listened to that, that's really good. It's a chance to kind of see the conversations that a lot of the expert programmers are having behind the scenes. It's basically just me talking to other advanced programmers and having the conversations that I would normally have with them, but just recording them. We have a mastermind group. We meet twice a month and we talk about various topics. It tends to be on the more advanced side, so it's intermediate to advanced. Certainly if you're a beginner, you can come, but I think to get the most out of it, you want to be on the intermediate to advanced side. If you're a beginner and you want to start a beginners group, we can talk about that. We have an online course called Using Git Effectively. Taylor's going to email you guys a discount code for that. But it's a pre-recorded course. It teaches you how to use Git, and it really teaches you some of the nuances and how to really use it effectively and create a good workflow. We have various workshops. So we teach DQMH training. We also have some stuff on unit testing, test-driven development, CI/CD stuff. We do one-on-one training, so that mentoring part that's missing from the NI training, we do that. And also the workshops are really good for that as well, because the workshops, oftentimes we do exercises and people bring their own code into the workshop. So we're learning test-driven development. We do some basic exercises on test-driven development so you understand what it is. And then you bring in your own code and we add a new feature to it using test-driven development. So those type of things. And then this SAS GCLI tools, I have a set of tools for CLI or for CI/CD stuff, and I'm making them public. It's not quite finished yet, but I put up a few of them. And my goal is to have that be a resource where people can go and basically you copy a few files, you do a little setup, and within like an hour, you've got this CI/CD pipeline set up that will build your code for you and test it and do all those things. It's not there yet, but I'm working on it. Some of the tools are there. But if you want to go look at that, that's good. And then lastly, next steps, we're doing a workshop at GDevCon NA. There's that link is to the syllabus for the Using Git Effectively. Taylor will send you the link to the discount. There's a sign up sheet for the mastermind. And if you want to do one-on-one workshops or training or any of that type of stuff, you can send us an email. Any questions, comments?
Yeah, Sam, thanks again for doing this. This is inspiring. I really appreciate it.
Yeah, thank you.
I echo the same thing. Thank you, Sam.
Yeah, I hope you guys found it useful, and I hope that go check out all these resources. There's a lot of resources out there. So, I mean, we offer a bunch of stuff, but there's plenty of other places to get all this information too.